Hello dear students, in today's class I will start to discuss about the diffraction of light. A very preliminary aspects of diffraction has been discussed during the classes of Huygens wave theory. A very preliminary effects I have discussed, that what is actually diffraction, that is light enters within the geometric shadow of any obstacle, and there are some type of distribution in the intensity pattern, and that is what we actually refer to as the diffraction. Actually diffraction and interference, it is very hard to distinguish between diffraction and interference diffraction এর মধ্যে পার্থক্য করাটা খুব কঠিন। এখানে যেটুকু পার্থক্য করতে পারি, whatever I can distinguish is that interference takes place from two different point sources, দুটো আলাদা point source থেকে আমরা নিই, whereas in diffraction a single source is capable of providing the intensity distribution pattern. And diffraction is basically due to the mutual interference. As I said, that it's very difficult to distinguish between them. Diffraction is a type of interference only. So diffraction, what actually happens is that it is the interference of the secondary disturbances originated from the primary wavefront. So you know that what is the primary wavefront. So at the primary wavefront, so in interference the light waves were coming from two different wavefronts. So you see that there are two slits over here. So there are some wavefronts from this one, some wavefronts from this one, and they mutually interfere to provide something. এবং এরা ইন্টারফেয়ার করে তুমি একটা কিছু দেখতে পাচ্ছ on the screen, that is what is interference. But in diffraction what actually happens is that you have a aperture like this, এরকম একটা aperture আছে, and you suppose that a plane wavefront is incident over here, এখানে একটা plane wavefront incident হলো, and from this plane wavefront, so you have the secondary disturbances from different points. So you have secondary disturbances from different points which actually interfere among themselves. এই একটাই ওয়েভফ্রন্ট থেকে লাইট এসে ইন্টারফেয়ার করে, from the same wavefront the light interferes, and that phenomena what I actually call the diffraction of light. So diffraction of light is the interference of the secondary wave disturbances generated from the primary wavefront. So প্রথম যে ওয়েভফ্রন্টটা আসলো সেই ওয়েভফ্রন্ট থেকে যে সেকেন্ডারি ডিস্টারবেন্স গুলো জেনারেট হবে, সেকেন্ডারি ডিস্টারবেন্সেস দ্যাট আর জেনারেটেড, so they interfere among themselves to give you the phenomena of diffraction. And here also you will see some intensity pattern on the screen. And so let us start the formal discussion over here. So formal discussion আমরা এখন থেকে শুরু করছি, and whatever I will do is that I put up a definition over here. So not definition particularly, introduction. So I will start with the introduction and then I will move forward with some other calculation. So when light from a narrow source, is incident on, when light from a narrow source is incident on a sharp obstacle, when light from a narrow source is incident on a sharp edge of an opaque obstacle, when light from a narrow source is incident on the sharp edge of an opaque obstacle, and definitely the dimension should be comparable to the wavelength of light, otherwise the phenomena is not noticeable. Dimension comparable to the wavelength, of light, comma, then there will be some illumination, up to certain extent, in the geometrical shadow of the obstacle, This shows that light can bend around the obstacle. Actually, this shows that light can bend around an obstacle, and the phenomena is called diffraction. So this is the phenomena of diffraction, that is, you get some light within the geometrical shadow. Now how to explain it? So at the very beginning days people thought that light bends. So প্রথম দিকে মানুষ ভেবেছিল যে লাইট হয়তো এখান থেকে বেন্ড করে যায়, so there is a bending of light. মানে আমি এরকম বলতে চাইছি, সাপোজ দিস ইজ অ্যান অবস্টাকল ওভার হিয়ার, সো এটা অবস্টাকল, অপেক অবস্টাকল, লাইট ক্যানট পাস থ্রু ইট, and you suppose that a plane wave front is incident on it, so একটা plane wave front এখানে incident হলো, so whatever you will find over here is that, তাহলে এখানে তুমি কি দেখতে পাবে, if a plane wave front is incident on this sample, so whatever you will find is that, so তুমি কি দেখতে পাবে এখানেতে, so you will see that if a plane wave front is incident and this is suppose the screen, so you must have light except this particular region, so সব জায়গাতে লাইট থাকবে, so you will get the light at all regions, but you shouldn't have any light within this particular region. So এই রিজনটার মধ্যে within this particular shade which I call AB suppose, so from A to B there shouldn't be any light, there shouldn't be any light because this is the obstacle in the system. So A থেকে B এইটুকু জায়গায় কোনো লাইট থাকার কথা নয়, there should not be any light, and the intensity at this point beyond the shadow, shadow বাইরে মানে outside of A and outside of B, you must get uniform illumination. But whatever you notice is that over beyond A and beyond B এই জায়গাগুলোতে ইউনিফর্ম ইলুমিনেশন থাকে না, here you don't have uniform illumination, rather you get a distribution like interference. Interference যেরকম distribution দেখেছিলে, here also you find a type of such distribution in the light intensity. This is the first point, and the second point is within this region A and B there is also some presence of light. A আর B এইটুকু জায়গার মধ্যেও তোমার কিন্তু লাইটের প্রেজেন্স আছে, from A to B also there is some presence of light in the system, that is what is going on, there is some presence of light in this system, right? So I hope that you are trying to get it, so তুমি নিশ্চয়ই বুঝতে পারছো. Now how to explain it? So from geometrical optics these don't have any explanation, very old theory of light due to Newton corpuscular theory, there is no explanation of this, so এটার কোনো explanation পাওয়া যাচ্ছিল না, people were not getting any explanation of this. So then the person who came into the picture, not only Huygens but Fresnel. So Huygens actually said, Huygens যেটা বলেছিল, every point of the wavefront is the source of secondary disturbances, just source, it is the source of secondary disturbances. But Fresnel came into the picture and said that these secondary disturbances interfere among themselves. So এখানে যে ওয়েভফ্রন্টটা পড়েছে, the wavefront that is present over here, so the waves can come from here and interfere at this particular region. So এখান থেকে waves এসে এই জায়গা থেকে the waves can interfere at this region, so there can be some interference, and it is the result of the interference that you have diffraction, that you have some non-uniform distribution, and also some type of light enters within the shadow region, এবং শ্যাডোর ভেতরেও তুমি এখানে লাইট তুমি পাবে, you get some light. So it is the diffraction what is actually going on. So এটা হচ্ছে diffraction. আগে মানুষ ভাবতো যে লাইট হয়তো বেন্ডিং অফ লাইট, হয়তো লাইটটা এখানে বেন্ড করেছে, so there has been some bending. চলো বেন্ডিং ক্যান এক্সপ্লেন, চলো উই টেক বেন্ডিং, চলো ধরে নিলাম লাইট বেন্ড করে, হ্যাঁ, সো ধরে নিলাম লাইট বেন্ড করে, suppose the light bends, so তাহলে তো শ্যাডোর ভেতর লাইটটা তুমি এক্সপ্লেন করতে পারবে, you can explain the light that is produced inside the shadow, but who will take care of the non-uniform distribution? Non-uniform distributionটা কে টেক কেয়ার করবে? Who will take care of the non-uniform distribution? I hope that I am able to make you understand. So non-uniform distribution তো তুমি তো বেন্ডিং দিয়ে তো এক্সপ্লেন করতে পারবে না পুরোপুরি, so that is what I would like to explain over here. তো সেটাই আমি তোমাদেরকে এখানে দেখাতে চাইছি. So চলো, বেসিকটা হচ্ছে not only the disturbance, দুটোই আছে, হ্যাঁ, that are non-uniform, both effects are to be taken care while explaining diffraction, that is the non-uniform distribution outside the shadow region and the entry of light within the shadow region, so both are to be discussed with proper care. Now come to the definition. According to Huygens, according to every point of a wavefront are the source of secondary disturbances. Every point of a wavefront are the source of secondary disturbances. Every point of a wavefront are the source of secondary disturbances. Fresnel suggested that these wavelets from the from the same wavefront, interfere among themselves, to produce a phenomena called diffraction. So that is what is the actual picture of diffraction. So etai hoche diffraction actual picture. So every point of a wavefront are the source of secondary disturbances, and Fresnel suggested that these wavelets from the same wavefront interfere among themselves to produce a phenomena called diffraction. Right? And the Fresnel's explanation of diffraction is quite more complicated, which we will be learning after a few days. Actually, the interference phenomena is divided into two different classes. One is called the Fraunhofer diffraction and another is called the Fresnel diffraction. Now, the Fraunhofer diffraction is due to the plane waves, that is the source and the screen are at infinite distances. So that is what is the Fraunhofer diffraction, and it is very easier to study. The mathematics of Fraunhofer diffraction is rather simple. So, and that is what you will be also studying in your laboratory. এবং সেটা তোমরা ল্যাবরেটরিতেও তোমরা করবে, particularly the experiment on grating. I hope that you have been doing the experiment on single slit, double slit. So these are a few experiments on diffraction that are incorporated in your syllabus. I hope that you have been performing in your laboratory courses about those experiments. But the Fresnel diffraction and the Fraunhofer diffraction, whereas Fresnel diffraction is rather easy to observe. Fresnel diffraction you can observe in your household also. So তুমি বাড়িতে বসেও Fresnel diffraction করতে পারবে, because in Fresnel diffraction no certain arrangements are required, just a source and the screen obstacle will do it. So screen source দিলেই তোমার এখানে কাজ হয়ে যাবে। But Fraunhofer diffraction যদি স্টাডি করতে হয়, if you want to study Fraunhofer diffraction, then you need a dedicated laboratory where you have the spectrometers, you have the collimator, telescope, the lenses and everything, because you need to make the arrangements in such a manner that the light is coming from infinity. তোমায় এমন অ্যারেঞ্জমেন্ট করতে হবে যাতে তোমায় মনে হবে যে লাইটটা যেন ইনফিনিটি থেকে আসছে, the light is coming from infinity and also it is reaching infinity. So there is the convex lens such that the light appears to come from infinity, and there is the convex lens which focuses the light on a screen as if it is placed at infinity. So these are the things that are going on. So at the very beginning, I will study the Fraunhofer diffraction for the next 3 to 4 classes, where we will also try to learn about the resolving power of different instruments. So including today's class, the next 4 classes will be dedicated towards Fraunhofer diffraction, because whatever I will be discussing in very details, such that no more discussion is required in your lifetime. So that type of discussion will be made in this type of classes. এমন ভাবেই করব যে আর কোনোদিনও কোনো ডিসকাশন দরকার পড়বে না, এটা থেকেই তুমি সব করতে পারবে। So 4 dedicated classes towards Fraunhofer diffraction, and then there may be two classes on Fresnel diffraction, and that will come to an end of this phenomena of diffraction. So I guess that next 6 classes will be completely dedicated towards the study of diffraction. I know that it will take some time, but you see that that if you want to learn the things, if you want to understand the things, you have to devote time. So as I am devoting the time with many number of classes, so you have to be a serious and devotee of physics, such that you can understand the things in a proper manner. So that's the enjoyment of learning. So let us now proceed with the classes of diffraction. So diffraction কত রকমের ক্লাসে হয় সেটা আমরা এখন নেক্সট দেখাতে চাইছি। So the next topic is classes of diffraction. So number 1 is the Fraunhofer diffraction. So Fraunhofer is the name of a physicist who has worked on this. In this type of diffraction, both the source and the screen are at infinite distance from the obstacle or aperture. So diffraction can also occur in aperture also, in the obstacle or aperture, right? The wavefront considered for analysis is plane. The wavefront considered for analysis is plane. So here I will be dealing with plane wavefront. So wavefront considered for analysis is plane. You see that aperture can also work out. Suppose a plane wavefront is incident on it. So এখানে একটা plane wave এখান দিয়ে যাচ্ছে, some plane wave is incident on it. So this one is the aperture, এটা ফাঁকা জায়গাটা. So on the screen you should notice light only in this position. There should not be any light beyond this point AB. এই AB পয়েন্টের বাইরে কিন্তু কোথাও লাইট থাকা উচিত নয়. There should not be any point beyond this AB, right? AB এর বাইরে কোথাও কোনো লাইট থাকা উচিত নয়. Beyond AB there should not be any light anywhere. There should not be any light anywhere beyond AB. But you will see that some light is present at these regions also, at beyond A and also beyond B. You will see some light, and also the light which enters AB, that is not uniform in nature, but there will be some distribution, some non-uniformity over there, and this non-uniformity is due to the phenomena of diffraction or the entry of light within the shadow region, that is also due to the diffraction. So that is what we are going to study over there. So সেই effect গুলো আমরা study করব. So either you need an obstacle or you need an aperture to observe the phenomena of diffraction. But here you see that both the source and the screen are at infinite distance from the obstacle or aperture. Now the idea is that if the things are at infinite, then how can I observe it? So ঘটনা যদি ইনফিনিটিতে ঘটে তাহলে আমি সেটাকে অবজার্ভ করব কি করে? So infinity মানে হচ্ছে একটা সোর্স. So infinity মানে if I say that with respect to this the things are at infinity, the optics arrangement are at the optics phenomena are occurring at infinity. যদি আমি বলি অপটিক্স এর ঘটনাগুলো ইনফিনিটিতে হচ্ছে, তার মানেটা কি? That means that the rays are coming from infinity. Rays গুলো ইনফিনিটি থেকে আসছে, right? And how can you say that the rays are coming from infinity? So is the source is at infinite? So no. What actually is done in practice is that you take a convex lens over here and the source is placed at the focus of the convex lens. এই সোর্সটাকে কনভেক্স লেন্সের ফোকাসে নেওয়া হয়. The source is taken at the focus of the convex lens, and you know that if the object is at the focus of the lens, so its image will be formed at infinity, right? জানো তো ফোকাসে যদি অবজেক্ট থাকে তাহলে এর ইমেজটা কোথায় হয়? 1/v plus 1/u equals to 1/f, right? Actually 1/v minus 1/u equals to 1/f. So if you use that over here, u মানে এখানেতে object distance, if you take u equals to f, so then you find very easily that your image will be formed, will be the real image definitely, that will be formed at infinity. তো সেই আমরা বুঝতেই পারছি তাহলে সেই ইনফিনিটিটা কোথায় তৈরি হবে? So the image will be produced at infinite distance. ঠিক আছে, তাহলে ইমেজটা তোমার ইনফাইনাইট ডিসটেন্সে তৈরি হবে. সো ইনফাইনাইট ডিসটেন্সে তৈরি হবে, তার মানে এটা কি হবে? দ্য রেজ উইল বিকাম প্যারালাল, রাইট? So to my obstacle, তার মানে আমার এখানে যে অ্যাপারচারটা আছে, সাপোজ I have the aperture, so now this aperture to this aperture the rays are coming in what ways? এটা কি করে আসছে? The ray is coming parallel. তাহলে আমার তো আর জানার দরকারই নেই যে লেফট সাইডে কি ছিল. সো আই নাও ডোন্ট হ্যাভ টু নো হোয়াট ইজ প্রেজেন্ট অন দ্য লেফট সাইড. আই হ্যাভ প্যারালাল রেজ, আমার কাছে প্যারালাল রেজ আছে. আমার কাছে মানে স্লিটের কাছে, টু দ্য স্লিট. So to the slit you have parallel rays. So to the slit it appears that okay I have parallel rays. So what to care? তার মানে স্লিটের কি মনে হচ্ছে? To the slit the rays are coming parallel. Basically you need plane wavefront for the analysis because plane wavefront are easier to deal with. Plane wave কে সহজে ডিল করা যায়, সেজন্য আমাদের এখানে plane wave দিয়ে কাজ হবে. I will be discussing with the plane wavefront. I hope that I have been able to make you understand. তোমাদের নিশ্চয়ই আমি বোঝাতে পারলাম. And after the diffraction phenomena also the same thing happens. So here if the rays are parallel that means they are meeting at infinity. তার মানে তারা ইনফিনিটিতে মিট করবে. সো টু দিস অ্যাপারচার, তাহলে আমাদের অ্যাপারচারটার কাছে the things are going to infinite distances, ঘটনাটা ইনফিনিটিতে চলে যাচ্ছে. বাট ইন অর্ডার টু হ্যাভ আ ভিউ অফ ইট, হোয়াট ডু আই ডু? আই টেক এ কনভেক্স লেন্স এন্ড আই পুট দ্য স্ক্রিন অন দ্য ফোকাস অফ ইট, এবং স্ক্রিনটাকে এই ফোকাসের মধ্যে রাখছি. I put the screen on the focus of this particular lens, so it will converge at the focus and I will be able to see the phenomena over here. So basically the source, by the use of the convex lens you are taking the source and the screen to infinity. So convex lens যদি দুদিকে ব্যবহার করি তাহলে যেটা হয়, if I use a convex lens over here then what actually happens is that the source and screen are actually shifted towards infinity, right? And in your experiment that you have done in your colleges, particularly for the experiment on grating or the experiment on double slit, single slit, right? So whatever you have to do, so ওখানে একটা নাম ছিল, so you have a name over there which is called the Schuster's method. If your teacher has introduced this to you, that's fine. If not, then it has been an, as I used to say, it has been an injustice to you if you have not done it. যদি এটা পড়াশোনা না করে থাকো তাহলে তুমি প্র্যাকটিক্যাল শেখোনি, you didn't learn about the practical and you will be in terrible difficulty in your future if you don't read this yourself. So I cannot do this because this doesn't come under my discussion. So but if anybody has any doubt or you need any discussion, so approach them, we can do something if you have not gone through it, but it is expected that it has been done by your laboratory instructor. So তোমাদের নিশ্চয়ই এটা করানো হয়েছে, if not then please read it yourself. This is not available in the theory books, but definitely you will get it in your practical books. So practical বইতে Schuster's method পাবে, in the internet there are various materials on Schuster's method, try to understand it. So this is the material, so this is something which is done such that the things are moved to infinity. পরিষ্কার বলতে গেলে এইটা, এবং কি করে করে সেটা তো প্র্যাকটিক্যাল ব্যাপার আছে, so that should be a practical thing. But whatever the interviewer generally asks, so ইন্টারভিউয়াররা যেটা জিজ্ঞাসা করে অনেক ভাইবাতে, সেটা তোমায় জিজ্ঞাসা করবে যে Schuster's method বলতে কি বোঝো, so what do you understand? So the simple answer to this, you remember, it will help you throughout your lifetime. In Fraunhofer diffraction, the source and the screen both should be at infinity, such that we can consider plane waves on either side of the diffracting element. Diffracting element এর দুই দিকেই আমি যাতে plane wave নিয়ে ভাবতে পারি, considering plane waves, so that is what is the requirement for Fraunhofer diffraction, right? So I have to take the source and the screen both at infinity, and this is actually done virtually by means of Schuster's method. তো Schuster's method এর মানে হচ্ছে ওই যে লেন্স গুলো, টু পুট দ্য লেন্স ইন সাচ এ ম্যানার, লেন্স গুলোকে এমন ভাবে তোমায় প্লেস করতে হবে, the telescope, the collimator, the lens can be moved forward backward. If somebody has used some binoculars, কেউ যদি কোনোদিনও কোনো বাইনোকুলার দূরবীন কেউ যদি ইউজ করে থাকো, বাইনোকুলার অনেক সময়, সো ইউ বাড়িতে থাকে আমাদের হাউসহোল্ড পারপাস, সামটাইমস উই ইউজ টু হ্যাভ ইট, সো অনেকের বাড়িতে কেউ ইউজ করে থাকতে পারো কোনো সময়, সামটাইমস ইন দ্য টুরিস্ট স্পট, ইফ ইউ গো টু সাম টুরিস্ট স্পট, so then also then there you may have some telescope to view some long distance object. ওখানেও তোমাদের কাছে টেলিস্কোপ থাকতে পারে লং ডিস্টেন্স অবজেক্ট দেখার জন্য, টুরিস্ট স্পট গুলোতে থাকে। সো তুমি দেখবে ওটা ফরওয়ার্ড ব্যাকওয়ার্ড মুভ করা যায়, ইউ ক্যান মুভ ইট ফরওয়ার্ড ব্যাকওয়ার্ড। সো ফরওয়ার্ড ব্যাকওয়ার্ড মুভমেন্ট মানে হচ্ছে ইউ আর অ্যাডজাস্টিং দ্য লেন্স সিস্টেম, রাইট? So in this Schuster's method you have to adjust the lens in such a manner such that the source comes at the focal point of the lens. Source যেটা ইউজ করছে সেটা যেন লেন্সের ফোকাল পয়েন্টে আছে, such that it is parallel rays and it is incident on the diffracting element. And again after diffraction you just use the lens in such a manner, lens is movable, so লেন্সটা এমন ভাবে ইউজ করতে হবে such that the screen comes to the focal point of that particular lens. স্ক্রিনটা যেন ওই লেন্সের ফোকাল পয়েন্টে চলে আসে, সেটাও আবার আমাদেরকে চিন্তা ভাবনা করে রাখতে হবে। So that is how you can move the things to infinity, and now you can study Fraunhofer diffraction. So that is why we say that in Fraunhofer diffraction the experimental arrangements are a bit difficult. Experimental arrangement গুলো Fraunhofer diffraction একটু ডিফিকাল্ট আছে, কিন্তু Fraunhofer diffraction স্টাডি করা এবং সিস্টেমটা অবটেন করা, to obtain the diffraction pattern is very simple. So if you have some hands-on training then you could have understand it better. So that's what you do in your laboratory course. And the Fresnel diffraction you can observe easily, but you need because in the Fresnel diffraction there is no such experimental arrangement. Experimental arrangement বলতে কিছু এখানে দরকার নেই, because you need nothing to be put at infinity, you can just view them easily. But Fresnel diffraction theory is difficult, because there you need to consider the spherical waves for point source, the cylindrical waves for linear source, and the theory is difficult. Fresnel diffraction is theory difficult, where you need the concept of half period zones. Usually half period zones are given in the book in such a manner that it is so simple, but the physics of it is really interesting, and there is some in-depth understanding is necessary for Fresnel diffraction, which we will do a bit later after a week once we become expert in the Fraunhofer type of diffraction. So Fraunhofer diffraction আমরা expert হয়ে গেলে তারপরে আমরা Fresnel diffraction এ আস্তে আস্তে করে মুভ করব। The wavefront considered for analysis is plane. So এখানে বেসিক্যালি যেটা করা হয় সেটা আমি এক লাইন লিখে দিচ্ছি, so I just write a line over here, just give me a minute for that, I need to search it from the book, এক মিনিট দাও আমাকে। I don't have the book right now with me, so I have to write myself. আর তো নিজেকেই লিখতে হবে এখন, বই পাচ্ছি না আমি। So two convex lenses are used in such a manner that the source and the screen, such that the source and the screen are effectively, reality to not effectively, are effectively moved to infinity, are effectively moved to infinity. বুঝতে পেরেছো? Not reality, but effectively they are moved to infinity. Two convex lenses are used on either side of the diffracting element, on either side of the diffracting element. Diffracting element মানে either it is an obstacle or it is an aperture, in such a manner that the source and the screen are effectively moved to infinity, are effectively moved to infinity. That's it. এটাই হচ্ছে আইডিয়া। ঠিক আছে? আর নেক্সট হচ্ছে তোমার ফ্রেনেল ক্লাস অফ ডিফ্রাকশন। ফ্রেনেল ডিফ্রাকশনে হচ্ছে ফ্রেনেলস ডিফ্রাকশন। প্রথম কিন্তু ফ্রেনেলস ডিফ্রাকশনই ডিসকভার হয়েছিল। ফ্রেনেলস ডিফ্রাকশন কেম ইনটু দ্য পিকচার ফার্স্ট বিকজ দিস ডু নট নিড এনি অ্যারেঞ্জমেন্ট, এটাতে কোনো অ্যারেঞ্জমেন্ট লাগে না, দিস ক্যান বি ভিউড নর্মালি। So and you see that Fresnel also suggested the diffraction. So diffraction is basically due to Fresnel. So diffraction এর যা ঘটনা তার জন্য Fresnel এর contribution is the most contribution based on the Huygens principle, right? So Fresnel's diffraction. In this type of diffraction, the source or the screen এখানেই লিখে দাও দাস and oblique or মানে either any of them or both, the source and the screen, the source and or the screen are at finite distances, are at finite distances from the diffracting element. Either both are at finite distance or any one of them is at finite distance. যে কোনো একজনকে ফাইনাইট ডিস্টেন্সে থাকতে হবে, এনি ওয়ান অফ দেম শুড বি ফাইনাইট ডিস্টেন্স। দ্য ওয়েভ ফ্রন্ট কনসিডার্ড ফর দ্য অ্যানালিসিস ইজ বেসিক্যালি সিলিন্ড্রিক্যাল অর স্ফেরিক্যাল। দ্য ওয়েভ ফ্রন্ট কনসিডার্ড ফর অ্যানালিসিস ইজ spherical or cylindrical. Okay, so that is the entire arrangement that I see over here. So আমাদের অ্যারেঞ্জমেন্টটা হয়ে গেল। নাও আই উইল বি স্টাডিং দ্য এক্সপ্লিসিট ডিফ্রাকশন। এবার আমরা এক্সপ্লিসিটলি ডিফ্রাকশন স্টাডি করব, and the first one that I am going to study over here is the diffraction. I will be studying Fraunhofer diffraction in these classes. Fraunhofer diffraction. There are 3 to 4 geometries over which you need to study Fraunhofer diffraction. Today I will be starting the discussion on single slit. আজকে যে ডিসকাশনটা আমরা করব সেটা হচ্ছে সিঙ্গেল স্লিট ডিফ্রাকশন। আজকের টাস্ক, টুডেস টাস্ক ইজ সিঙ্গেল স্লিট ডিফ্রাকশন। সো লেট আস গো ফর ইট। এক্সকিউজ মি। First of all, let me draw the arrangement. What do we mean by a single slit? Single slit মানে হচ্ছে একটা rectangular aperture, মানে এখানকার অ্যাপারচারটা একটা রেক্ট্যাঙ্গুলার মতন। সো ইট ইজ আ রেক্ট্যাঙ্গুলার অ্যাপারচার। সাপোজ ইউ হ্যাভ a A4 size paper and in that A4 size paper, ধরে নাও এইটা তোমার পেপারটা, হ্যাঁ, দিস ওয়ান ইজ দ্য ক্রস সেকশন। এই পেপারটার মধ্যে তুমি একটা ছোট এরকম কাটলে, ইউ জাস্ট কাট আউট, ইউ মেক এ দিস কাট আউট, সো দ্যাট মেক্স ইট আ স্লিট। বাট দিস স্লিট ইজ নট এ সিঙ্গেল স্লিট, এটাকে বলা হচ্ছে রেক্ট্যাঙ্গুলার স্লিট। দিস ওয়ান ইজ কল্ড এ রেক্ট্যাঙ্গুলার স্লিট। নাও দিস উইল বিকাম আ সিঙ্গেল স্লিট। সিঙ্গেল স্লিট মানে একটাই স্লিট। Later you will study double slit. So now the slit that I need, actually the breadth is very small. So আমার কাছে যেটা স্লিট আমি নেবো, the slit that I will be considering, the breadth is very small but the length will be larger. Lengthটা অনেক বড় হবে। Okay, so that type of slits we are considering over here, because if I consider the rectangular slit, so then I have to take the care of another dimension. তাহলে এখানে আরেকটা ডাইমেনশন আমাকে টেক কেয়ার করতে হবে, but I am taking the one dimensional slits. Okay, so the breadth is not, yeah, so the breadth is as much small as possible. So breadthটা যতটা সম্ভব আমরা স্মল রাখবো এখানে। We'll keep the breadth as much small as possible for our proper understanding. ঠিক আছে। সো এটা আমরা যতটা সম্ভব আমরা ছোট রাখার চেষ্টা করব দ্য ব্রেথ। ওকে, সো নাও লেট আস স্টার্ট দ্য ডিসকাশন। এখানে এক লাইন লিখে দেওয়া ভালো, সো আই রাইট এ লাইন। A single slit is a rectangular aperture. A single slit is a rectangular aperture. Is a rectangular aperture. A single slit is a rectangular aperture of large length. Of large length. Is a rectangular aperture of large length compared to its breadth. ঠিক আছে, এইটাই। A single slit is a rectangular aperture of large length compared to its breadth. ঠিক, that's the idea. Now I draw the pattern over here. So pattern টা দেখিয়ে দিই একটু। Basically here I have a convex lens. Okay, this dashed line is the convex lens. I don't draw the entire lens. আমি পুরো লেন্সটা এখানে ড্র করছি না। I just draw the that central line of the lens. আমি লেন্সের সেন্ট্রাল লাইনটা ড্র করেছি। I did not draw the entire lens over here to avoid the complexity in the diagram. পুরো লেন্সটা আঁকলে না ডায়াগ্রামটা খারাপ হয়ে যাবে। The diagram will look bad. So that's why I have avoided it. So you may follow your textbooks for a proper diagram. So proper diagram বই থেকে দেখে নিও তোমরা, you just follow it from the book. So that is what I draw it over here for your basic understanding. So basic understanding এর জন্য আমরা এরকম করে করছি। So you see that there is a wave front. So এখানে কিন্তু একটা wave front ছিল, so there is a plane wave front over here, and you see that from this wave front the secondary disturbances originate. You see that from this point the disturbances originate over here, তাই না? এখান থেকে disturbance originate করছে, from here the disturbance originate. So I have taken 3 standard points. There are other points also in between. So আরো অন্যান্য পয়েন্টও আছে এখানে, there are other points also that will also give rise to that pattern over here, এবং সেখান থেকেও তুমি প্যাটার্ন পাবে, you will get other patterns at other angles. So this one is for the point P is generated at a particular angle. Point P টা আমরা একটা particular angle এর জন্য পেয়েছি, this point P. Suppose this angle is my theta over here, so all of them are at angle theta. This theta is called the angle of diffraction over here. So এটাকে আমরা angle of diffraction বলি, and if you just change this angle, so then you will get other points like O and P. And at the point P, not only the rays come from these 3 particular points. I have taken 3 standard points. One is the topmost, bottommost, and the midpoint. But there are other points also from where the rays actually meet at the point P. So অন্যান্য পয়েন্ট থেকেও P তে কিন্তু রে এখানেতে মিট করবে. So from the other points also the ray will definitely meet at the point P. So those phenomena are continuously going on over here. তো সেই ঘটনা এখানে সবসময় কিন্তু চলছে. The phenomena is going on over here. Okay. So I have shown you that how the pattern is formed over here. So now this point P can be a bright point, it can be a dark point, and something else. And you also see that this point P is rather outside the it is within the geometric shadow. So দেখো এই পয়েন্ট পিটা কিন্তু জিওমেট্রিক শ্যাডোর মধ্যে গিয়ে পড়েছে. সো বাই দিস আই অ্যাকচুয়ালি ওয়ান্ট টু শো ইউ দ্যাট হাউ দ্য লাইট অ্যাকচুয়ালি প্রপাগেটস ইনটু দ্য জিওমেট্রিক্যাল শ্যাডো. কি করে জিওমেট্রিক্যাল শ্যাডোতে লাইটটা চলে যায় সেটাও কিন্তু এখান থেকে দেখানো গেল. দ্যাট ইজ অলসো পসিবল টু বি শোন দ্যাট হাউ দ্য লাইট অ্যাকচুয়ালি এন্টার্স উইদিন দ্য জিওমেট্রিক শ্যাডো. আই হোপ দ্যাট you have got the issues. So once these fundamental things are understood by you, so now I may go for the other in-depth calculations and issues. So বাকি calculations গুলো আমরা এবার এখান থেকে দেখব. খুব ইন্টারেস্টিং, হ্যাঁ, এবং বেশি কঠিন না, not too difficult. You just follow the classes as I am proceeding. I hope that you will definitely understand everything that is being discussed with you. So chalo, the source, now everything is said. Okay, the next 30 minutes I hope that you will learn a lot. The source is illuminated. The source is illuminated by a source. The source is illuminated by a source. Source na, the slit hobe. The slit is illuminated. The slit is illuminated by a source of light. By a source of light of wavelength. By a source of light of wavelength lambda. And at the very beginning, ধরো পরীক্ষাতে সিঙ্গেল স্লিট আসলে at the very beginning of the exam, if you have single slit, you give an idea of the Fraunhofer diffraction. That is, you have already written that there are two lenses and everything. I don't actually draw the left side lens. আমরা left side এর লেন্সটা ড্রই করিনি এখানে. We did not draw that particular lens. We have taken the rays to be parallel. And on the right side, I have just shown the central line of the lens. তো এটাকে তুমি লেন্স বলে লিখে রাখতে পারো. হ্যাঁ, এটা হচ্ছে লেন্সটা. Please write it. Otherwise people will not understand. Convex lens. And if you are expert in drawing, তুমি যদি ভালো ছবি আঁকতে পারো, many students I hope that they can draw very well, so you draw the lens also over here. যারা ভালো আঁকতে পারো তারা এখানে লেন্স একটা এঁকে দিও. আমি আঁকলে দেখো এই যে বাজে লাগছে দেখতে, it looks very bad, so that's why I did not do. Okay, so those who are expert, you can draw a lens over here. I just take just a proxy of the lens by this line. The slit is illuminated by a source of wavelength lambda. Is illuminated by a source of wavelength lambda. And the screen is placed, কোথায় প্লেস করেছে বলো তো স্ক্রিনটা? On the focal plane. The screen is placed on the focal plane of the screen is placed on the focal plane of the lens. যেরকম তুমি পড়েছিলে না ইন্টারফারেন্সে localized at infinity, so same that type of things. The image is localized at infinity and you bring it at this focus. And the screen is placed on the focal plane of the lens. We want to find the resultant intensity. We want to find the resultant intensity. We want to find the resultant intensity distribution. We want to find the resultant intensity distribution on the screen. On the screen due to the diffraction of light from the slit. Due to the diffraction of light from the screen. Due to the diffraction of light from the screen. Fine. Here A is the slit width. A হচ্ছে slit width. This is the width of the slit. Slit width. That how much opening is allowed over here. কতটা opening allow করেছি সেটা হচ্ছে তোমার slit width. That is the slit width over here, right? This is the slit width. And theta is the angle of diffraction. Slit width and the angle of diffraction. Fine. এইবার the next, the disturbance incident on the slit, the disturbance incident on the slit The disturbance incident on the slit is, okay, so how much is the disturbance that is incident on the slit? So suppose I take y equals to c into e to the power I omega t. This is the equation of a plane wavefront. There is no dependence upon the distance. So distance এর উপর কোনো dependence নেই, it is same everywhere. So c e to the power I omega t ধরো এই জায়গাটাতে c e to the power I omega t is at this position I consider. Right? So now as the waves are moving at further distances, so then there will be some phase differences, path difference and phase difference, right? So there is a path difference and the phase difference will be introduced between them. তাহলে এদের মধ্যে path difference আর phase difference থাকবে। দেখা যাক কি হয়। So let us try to find. So this is the total disturbance incident on the slit. So what is the disturbance per unit width? So the disturbance per unit width of the slit, per unit width of the slit, disturbance per unit width, তাহলে unit width এ কত আসবে? So that should be definitely equals to some c by a e to the power I omega t per unit width. So I divide by the width per unit, unitary method, okay, ঐকিক পদ্ধতিতে পাওয়া গেল। আচ্ছা, এইটুকু অবধি আসলো। Now I consider a magnified version of this diagram. এবার আমি এই ডায়াগ্রামটার একটা ম্যাগনিফাইড ভার্সন ড্র করছি। এটা উইথটা অনেক বাড়িয়ে দিলাম, হ্যাঁ, ম্যাগনিফাই করে দেখাচ্ছি এখন। সো নাও আই জাস্ট ম্যাগনিফাই দ্য সিস্টেম এন্ড ওয়ান্ট টু শো ইট টু ইউ। সো ম্যাগনিফাইড অবস্থায় দেখাচ্ছি। হোপফুলি দিস অ্যাপিয়ার্স টু বি মিড পয়েন্ট। ইয়া ফাইন, মিড পয়েন্ট হয়েছে আমার। সো দ্যাট ইজ মাই মিড পয়েন্ট। And what is actually going on over here is that I am interested in that point P. So এখান থেকে ধরো একটা রে যাচ্ছে। So I take a very small element over here. So আমি ধরো এখানে একটা স্মল এলিমেন্ট নিচ্ছি। I take a small element over here. স্লিটের এখানে আমি একটা স্মল এলিমেন্ট নিলাম, which I call dz. এই এলিমেন্টটাকে আমি dz বলছি। ফ্যান্টাস্টিক, আন্ডারস্টুড। এখান থেকে লাইট পিতে যাচ্ছিল, from where light was traveling towards p. From here also it will travel towards p. That is that angle theta. So এটা angle theta যে লাইট গুলো, the light which are traveling at angle theta. I don't draw the entire right side, I just write 2p, মানে p এর দিকে এটা যাচ্ছে, রাইট? এই যে p পয়েন্টটা, জাস্ট হ্যাভ আ লুক, এই যে p এর দিকে যাচ্ছে, the light is proceeding towards p. So no need to draw all this junk, এগুলো ড্র করার দরকার নেই, এটা দিলেই হবে। You will understand that this much sufficient. This distance is z. এই যে এলিমেন্টটা কনসিডার করেছি, এটা z ডিস্টেন্সে কনসিডার করেছি। You try to understand the single slit properly, because from the next class it will be the double slit, then it will be multiple slit, but the idea is same. So you just try to understand the single slit. The other issues of diffraction will be just very easy. It will appear very simple to you. So once I just make you understand about the different ideas, it will appear simple. So এই জিওমেট্রিটা ভালো করে বুঝে নাও। You just try to understand this geometry, everything else will be fine. If I want to path difference, if I want to find the path difference, so by this time you know how to calculate path difference. তোমরা জানো কি করে path difference বের করতে হয়, right? You know that how to calculate path difference of this particular system. So you just join these two. So that is how you get the path difference of this particular system. This one is the perpendicular line that you draw. So এটা perpendicular line আমরা draw করলাম। And from geometry we know that if this angle is theta, এই অ্যাঙ্গেলটা যদি থিটা হয় না, if this angle is theta and this angle is 90 degree, so then from geometry this is theta. এটা তোমাদের টাস্ক, এটা নিজেরা করবে। So this is what you will do over here. And what is the path difference basically? So the path difference basically over here will be, if I give some name to this particular points, এই পয়েন্ট গুলোকে যদি আমি একটু নাম দিয়ে রাখি, what should I put? O has been used over here. একবার ওটা ব্যবহৃত হয়ে গেছে। C is also used. Suppose I call it M, midpoint M, and this point I call it suppose N. So from this geometry you can say that what is the value of the sin theta. So এখান থেকে sin theta এর ভ্যালুটা কত আসবে? This is right angle. So sin theta is perpendicular by hypotenuse. That means it is Mn by Mq. So what is then Mn? So Mn is equals to Mq মানে হচ্ছে Z. So that comes out to be Z sin theta. Okay. So mn comes out to be z sin theta. And this is the path difference actually. This is the path difference between the two rays that I have shown you. So যেই দুটো রে এখানে দেখালাম তাদের মধ্যে পাথ ডিফারেন্স হচ্ছে এইটা। থিটা অ্যাঙ্গেলে যেই রে গুলো ডিফ্রাক্টেড হয়েছে, দ্য রেজ হুইচ আর ডিফ্রাক্টেড এট অ্যান অ্যাঙ্গেল থিটা, ভালো করে বোঝো, আই কনসিডার দ্য সেট অফ রেজ দ্যাট হ্যাভ বিন ডিফ্রাক্টেড বাই অ্যান অ্যাঙ্গেল থিটা and they finally produce the ultimate image at the point P. The effect is produced at P. So what I have done is that, তো যেটা এখানে আমি করলাম সেটা হচ্ছে I consider a small element dz at a distance z from the midpoint or from the center. Center থেকে আমি z distance একটা ছোট এলিমেন্ট নিলাম dz. So dz থেকেও একটা রে বেরোচ্ছে, a ray comes from dz and the ray comes from m. In my previous diagram I have shown the rays to come from the midpoint and the rays to come from the top and the bottom point. সব জায়গা থেকে রে গুলো এরকম কিন্তু আছে, the rays are over here. But for my particular analysis I am just showing these two. There are many such, এখানে পুরো জায়গাটা জুড়েই তো এরকম আছে, there are so many rays at an angle theta and by the virtue of lengths they all together meet at the point P. So this is the phenomena which I have. But for the clarity of the diagram I don't show all this, I just show only these two. বাকিরাও কিন্তু আছে, the others are definitely present. So let me write over here that what I am trying to do. So কি করতে চাইছি সেটা লিখি এখানটাতে। We consider an element dz, we consider an element dz at capital Q which is at a distance small capital M, which is at a distance z, which is at a distance z from the center within bracket capital M from the center of the slit, which is at a distance capital N from the center of the slit, right? If r be the distance, এই যে এই ডিসটেন্সটা হচ্ছে r, এই যে এইখানে এটা হচ্ছে r, this distance is r, q থেকে p, that distance is r, and from the midpoint the distance is r0. Okay, these are the two distances. If r be the distance, if r be the distance of capital P, if r be the distance of capital P from dz, if r be the distance of capital P from dz, then what actually happens is that if r be the distance of capital P from dz, so then what happens is that you may write it to be then the disturbance at capital P due to dz will be, what is the effect of dz at capital P? If r be the distance of capital P from dz, then the disturbance at capital P due to dz will be, disturbance মানে the effect of the wave, so I call it dyp, right? Why do I call it yp? The effect at the point capital P, so that's why yp. Y is what? Y was the initial displacement, and now this one I write yp, the effect at the point capital P, so that's why yp. Why do I write a d? D কেন লিখছি? So I write a d over here, so ওখানে একটা d লিখতে হবে, so you have to write a d over here because it is due to the small element dz, যেহেতু small element dz এর জন্য, so that is why you write dyp, and this turns out to be, this dyp will turn out to be c by a e to the power I omega t minus kr into dz. Now understand why. This is the effect per unit width, this is the effect per unit length. So what is the effect for dz length? Per unit length যদি এইটা হয় তাহলে dz length কত হবে? This multiplied to dz, and from the wave theory you know that you have to take care of the path difference or the phase difference. Path difference, phase difference এগুলো তোমায় টেক কেয়ার করতে হবে, তা নাহলে দুটো পয়েন্টে ডিস্টিংগুইশ করবে কি করে? If you don't take the path difference, phase difference, how will you distinguish between the 2 points? So in order to distinguish that, you write it over here, it is dz. You write it omega t minus kr. আর তুমি জানো, if the disturbance over here is something e to the power I omega t, so at a distance x it will be I omega t minus kx, and that is what I call a progressive wave. তাকেই তো progressive wave বলা হয়, e to the power I omega t and then it is e to the power I omega t minus kx. That is the wave is advancing. Otherwise that would have been a stationary wave. তাহলে তো stationary wave হয়ে যেত। তাহলে e to the power I omega t minus kr, that is the wave disturbance that is you have at the point P. বোঝা যাচ্ছে পি পয়েন্টে কি আসলো? তো পি পয়েন্টে কি দেখতে পাচ্ছ? দ্য ডিস্টারবেন্স এট দ্য পয়েন্ট পি। ইউ সি দ্যাট আই এম গোয়িং ভেরি স্লো ফর ইউর প্রপার আন্ডারস্ট্যান্ডিং। আমরা খুব স্লো চলছি যাতে তুমি ভালোভাবে জিনিসটা বুঝতে পারো, বিকজ ফর দ্য নেক্সট 2 ক্লাসেস আফটার টুডেস ক্লাস, দ্য নেক্সট 2 ক্লাসেস the things will be the same. The first part of the discussion will be more or less same. So once you understand, so then I can just say that you have already learned so from there. Okay, so ভালো করে বুঝে নাও, e to the power I omega t was at the slit region, and as you are moving there should be some minus kx wala term. So minus kx term এখানে থাকবে, so minus kr over here, so that distance is r. Got it? ঠিক আছে, হয়ে গেল। আচ্ছা, r মানে আমরা এখানে কি লিখতে পারি? So if I call it some limit, here I can write that r is equals to what? So r is equals to r0 minus of mn, লিখতে পারি তো? r equals to r0 minus of mn. This is r0, and if I subtract this mn part, so then you get the same thing. Got it? তার মানে r মানে কি লিখতে পারি? From the r0 you subtract mn part, and that is the path difference between these two rays. এই দুটো রে এর মধ্যে path difference তাই আছে। তাহলে I can write it r0 minus of z sin theta. I write it r0 minus of z sin theta. Okay, plug in over here. So এটা এখানে plug in করে দাও। তাহলে এখন মানুষ জিজ্ঞাসা করবে যে স্যার তাহলে r0 কি? হোয়াট ইজ r0? r0 টা হচ্ছে, r0 is the value of r at z equals to 0. r0 is the value of r at z equals to 0. If you put z equals to 0, you get r equals to r0. আর z equals to 0 মানে কি? The center. I have said that the center is at the point m. Centerটা z equals to 0 তে আছে, and on both sides the z values are increasing. So that is what is the idea you have. So on the next line you may write it. Each and every points you see that I am trying to explain you in very details. আরেক জায়গায় যদি এইটা বসাও r0 and this one, so there will be 2 parts in the exponential. I skip a step over here, আমি একটা স্টেপ জাম্প করলাম। সো একটা হচ্ছে e to the power I omega t minus kr0, আর একটা হচ্ছে e to the power I into z sin theta, e to the power I into z sin theta, right? And then there is a dz. Fine, যা ছিল সব পুট করে দিয়েছি, I have put everything over here. Now this is further simplified. এটাকে আমি আরেকটু সিম্পলিফাই করে নেব। I will try to simplify this further. কি মিস করলাম বলো তো? কে টা মিস করে গেছে। I have missed a k over here. That is the demerit of skipping the steps. K into r, so k into r0 and k into z sin theta. So k into z sin of theta. Fantastic. হয়ে গেল। c by a, and this one I write capital R. এইটাকে আমি লিখবো ক্যাপিটাল R, and here I write e to the power I beta z dz. Now what is my beta over here? So that is what I should also write. সেখানে বিটা জিনিসটা কি? What is the beta? So here beta is I and z you leave out, so beta is k sin theta. So beta is k sin theta. And what is capital R? Capital R is c by a e to the power I omega t minus k r3. Okay, so everything is well settled now. সবকিছু প্রপার ওয়েতে আমরা সেটেল করে দিয়েছি, everything is well settled now. So we just need to proceed with the calculation. So ক্যালকুলেশনটাকে প্রসিড করে নিয়ে যেতে হবে। Fine. So this is what you have at this moment. So this dyp equals to 8. Let me box it for the proper highlight. So it will be highlighted. So এরকম ভাবে থাক। Okay, dyp is r e to the power I beta z multiplied to dz. So this is the effect of this small element dz at the point P. তুমি কি বুঝতে পারছো dz থেকে যেটা বের হচ্ছে, something which is coming from dz, that is the secondary disturbances of high gain. So এটাই হচ্ছে হাই গেনের সেকেন্ডারি ডিস্টারবেন্স। ফিজিক্সটা বুঝতে বুঝতে যেতে হবে, নট অনলি ম্যাথামেটিক্স। ম্যাথামেটিক্স তোমাকে ডিজেড এফেক্ট, দ্য এফেক্ট ডিউ টু ডিজেড এট দ্য পয়েন্ট পি বলে দিয়েছে। দ্য এফেক্ট অফ দ্য এন্টায়ার স্লিট ইউ নো, you take it per unit with, and what is the effect of that unit, of that small unit dz at the point p, taking care of the phase difference has been taken at the point on the screen. What you are actually doing and why you are doing this, কেন করছো এটা, you will get marks fine, but you should understand that why you are doing, কেন এটা করলাম বলো তো। This is because of the Huygens principle. Every point of the primary wavefront that is incident on the slit is the source of secondary disturbances, and that is why dz is also a source of secondary disturbance, and I want to find the effect of that secondary disturbance at the point p, এবং সেই secondary disturbance এর effectটা আমরা p পয়েন্টে দেখতে চাইছি। Okay, understood? This is Huygens part. Now you will have the Fresnel part. Fresnel কি বলছে? According to Fresnel, these secondary disturbances mutually interfere. এই secondary disturbance গুলো নিজেদের মধ্যে ইন্টারফারেন্স করবে। That means you have to sum over. তার মানে তোমাকে সাম করতে হবে y1 plus y2 plus y3. That is what is interference, y1 plus y2. On the first class of interference you have seen there are two sources, y1 and y2, and what was their effect at some point. So এখন তাহলে এটাকে সাম করতে হবে। But these sources are not discrete, but they are continuous. You have the idea of continuous and discrete from many other branches of physics. Continuous mass, you used to write integration dm. Discrete mass, you used to write m1 plus m2 plus m3, something like that. So that is the way you are propagating, you are just proceeding in your discussions. তার মানে হাইগেনের পার্টটা হয়ে গেছে, that dz is the source of secondary disturbance, and now I need to consider the Fresnel part, that these dyp's from other elements, these dyp's from other elements like dz, they will interfere among themselves. Interference মানে you have to plus, you have to add up, and here you have to integrate. এখানে কিন্তু ইন্টিগ্রেট করতে হবে। ওকে, বুঝে বুঝে এগোতে হবে। You have to understand and then proceed. So right, so the resultant disturbance, at p, so the resultant disturbance at p due to the entire slit, so the resultant disturbance at p due to the entire slit will be how much? তাহলে p তে net disturbance কত হবে? That is yp. Yp will be what? That should be an integration of this d of yp, d of yp, and the range of integral is from minus a by 2 to plus a by 2. The value of z minus a by 2, so z equals to 0. I have taken the center, r0 is the value at r equals to, at z equals to 0. So this is my z equals to 0. So as you move from z equals to 0 upward, you move plus a by 2. So this point is actually my plus a by 2, and this point is my minus a by 2, because the entire slit width is how much? পুরো স্লিটের উইডথটা কত আছে? a আছে। The entire slit width is a, so I move a by 2, a by 2 upward, downward. That's it. So এটা কাজ করো, so you just work with this, you will effectively get the idea. So এটা নিয়ে কাজ করো, পেয়ে যাবে সব কিছু, you will get everything. So integration of minus a by 2 to plus a by 2, capital R e to the power I beta z dz. So this you just proceed with a very simple type of integration. That should be capital R by I beta e to the power I beta a by 2 minus of e to the power minus I beta a by 2. I have skipped the steps definitely. I mean step আমরা skip করেছি। আচ্ছা, এটাকে আমি sin theta ফর্মে লিখতে পারি from the rules of that Euler's theorem, you know it. So r by কি লিখবে এটাকে বলো তো দেখি, r by beta twice r by beta e to the power I beta a by 2 minus e to the power minus I beta a by 2 divided by twice I. Right? I was already present. I have just taken care of the 2. And this gives me sine of beta. So twice r by beta this gives me sine of beta A by 2. Got the idea? So now here whatever I will do, I will put the value of this capital R. So if I put the value of capital R, it was C e to the power C by A most probably, capital R C by A, C by A exponential, C by A, C by A exponential I omega t minus k r 0 sine of beta A by 2. Or I can write yp equals to C I separate out, exponential part I separate out. These are not of too importance. Important জায়গা হচ্ছে এইটা, sine of beta A by 2 divided by beta A by 2. So that is the entire picture that you have over here for this yp. So I have written it in a neat and clean way, separating properly. So C by A, so sorry, C e to the power I this portion, and then sine of beta A by 2. Okay, and what is this beta? So I shouldn't box this, I should write another line. আরেকটা লাইন লিখে box. Yp comes out to be some C e to the power I omega t minus kr0, and then it is sine of alpha divided by alpha, where alpha is equals to beta A by 2. You must remember alpha is equals to beta A by 2. And now you just try to highlight this. Yeah, that's fine. ঠিক আছে একদম, that's fine. So that is how I get my yp. So from here now let me calculate the conjugate of yp, because finally I need to find the intensity, and intensity is yp star. So it will become some cc is real quantity. This will become e to the power minus omega t minus kr0 sine of alpha by alpha. So therefore intensity at the point capital P, therefore intensity at capital P, what is the intensity at capital P? So that should be ip is equals to yp star. If yp is real, then it is yp square, you know. So yp যদি real হয় তাহলে yp square হয়, but এখানে real part নয়, so that is why you need to take the conjugate. The equivalent of square in real is equivalent to conjugation in complex algebra. So this comes out to be c square, exponential cancels out, and this is sine alpha by alpha, this sine alpha by alpha whole square. And let me write this portion to be I0, এবং এটাকে আমি I0 বলছি, so it is some I0 sine square alpha by alpha square IP. So henceforth I will be dealing with the I0 only. So এরপর থেকে আমরা শুধু এই I0 নিয়েই ডিল করব. I will be dealing with this I0 component only. Okay, so this is the intensity pattern that you will find on the screen. So এটাই হচ্ছে intensity distribution pattern due to a single slit, and you see that there is a distribution depending upon alpha. Alpha depends upon beta and beta depends upon theta. Okay, you see কিরকম রিলেশন দেখো, alpha আছে finally, alpha depends upon beta, beta depends upon theta, and theta is the angle of diffraction. So that means that as you are changing the angle of diffraction, you will get the things accordingly, এবং সেইভাবে তুমি এটা accordingly পেতে থাকবে, right? And you may also enter within the shadow region, এবং shadow region এও তুমি ঢুকে যাবে কি করে, how you see that the lights are, this one is the shadow region, so এই লাইনের বাইরে মানে shadow, but you see that you are, if there is the screen, so you shouldn't have any light after this, এই জায়গাটার পরে লাইট থাকা উচিত না according to geometrical optics, but you see that the light is entering definitely, so definitely light shadow region এ ঢুকছে, but the intensity will diminish on either sides, কিন্তু ইন্টেন্সিটিটা ডিমিনিশ করবে, মানে as you are moving a few orders inside the shadow region, you will see that the light decreases and ultimately it will be zero. So that is the effect that we are going to study next, এবং সেটা আমরা এখন দেখব। আচ্ছা, so এখানে লিখে নি, so this is the intensity distribution function, this is the intensity distribution function for the single slit, this is the intensity distribution function, this is the intensity distribution function which we will call IDF, standard is called intensity distribution for the single slit diffraction, for the single slit diffraction. ঠিক আছে, intensity distribution টা হয়ে গেল। Let us now analyze the position of the maxima and minima. যেরকম ইন্টারফারেন্স করেছেন, in the interference here also we will do. Let us now analyze the position of the maxima and minima. Position of maxima and minima. Some people write maximas and minimas. Don't write maximas and minimas because already they are plural. Maxima is plural, minima is plural. So let us now analyze the position of the maxima and minima of the IDF. So IDF এর কোথায় maxima কোথায় minima আছে সেটা আমরা খুঁজে বের করে দেখব। Now concentrate. First of all, you will require the theory of limits. So here you will require the classes that you have studied at the very beginning of the first semester course on mathematical physics. Maybe you have been wondering that why those were taught. So now you will have some practical applications of those. এবার এখন তুমি practically শিখবে যে কেন এগুলো পড়ানো হয়েছিল। You see that when alpha equals to 0, what happens? So first of all, I put up a heading and write principal maxima. Principal maxima মানে এটা হচ্ছে principal maxima, principal of a college, right? Head of all the teachers and all the students. So principal. So principal maxima. Maxima means the bright point, but this is the brightest. There are bright points and this is the brightest. সবথেকে বড় maxima. So principal maxima. How it is obtained? So you see that when alpha tends to 0, মানে basically when theta tends to 0, when alpha tends to 0, within bracket I write theta tends to 0, that is the normal light that is going through the aperture or your slit. So when alpha tends to 0, you see that then IP is equals to 0/0 form, right? A limiting condition. So 0/0, you know, it is not absurd or undefined, but it is a limiting condition, and for which you can find the proper values under proper circumstances. So when alpha tends to 0, the IP equals to 0/0, a limiting condition, and you may take care of the limits over here. এবং সেটা আমি take care করে বের করে দেবো। So what is that? So IP turns out to be some I0 limit alpha tends to 0, and you may have a look over here, that is sin alpha by alpha whole square. ঠিক আছে, করা যেতে পারে। তো you can do this very effectively, you can do this because you find that it is 0/0 form, so you have to take limits over here. So তোমাকে এখানে লিমিট নিতে হবে। So once you take the limits, it is sin alpha by alpha, and you know that what is sin alpha by alpha. So that turns out to be I0. So therefore IP equals to I0. Okay, and this is the maximum possible intensity in the system. So এটাই কিন্তু সিস্টেমের maximum possible intensity, because you see that there is no dependence upon angle. So কোনো অ্যাঙ্গেলের উপর কিন্তু কোনো ডিপেন্ডেন্স এখানেতে নেই। This is the central maxima or the principal maxima, right, of maximum intensity. So this is the principal or the central maxima correspond to maximum intensity. This is the central oblique principal, central or principal. This is the central or principal maxima having maximum intensity. Air intensity সব থেকে বেশি হয়। This is the maximum intensity. There are other maxima also, but their intensities are lesser, as you will see within the next 10 to 15 minutes. তো সেটাও তুমি দেখতে পাবে। আচ্ছা, এবার বাকি ম্যাক্সিমা মিনিমা গুলোর জন্য, ফর আদার ম্যাক্সিমা মিনিমা we do the following. For other maxima and minima, for other maxima or minima, what will we do? For other maxima or minima, what I will do is that অন্যান্য গুলোর জন্য we set, for other maxima or minima we set dip d alpha, I set it to be 0. dy dx, the derivative, the first derivative is 0, that means you have reached a maxima or a minima point. First derivative is 0, that means we have reached a maxima or minima point, right? It can be maxima, it can be minima. Calculate করে দেখা যাক, let us calculate and see what happens. So this is basically dd alpha of that sin square alpha by alpha square. So this is basically dd alpha of sin square alpha by alpha square, and that comes out to be 0. So if I go for this differentiation, this will be some alpha to the power 4 on the denominator, alpha square 2 sin alpha cos alpha minus twice alpha sin square alpha, right? নিচেরটা ইনটু উপরেরটার ডেরিভেটিভ মাইনাস উপরেরটা ইনটু নিচেরটার ডেরিভেটিভ, denominator derivative of the numerator minus numerator derivative of the denominator. We have done it. Don't cancel out terms from both sides, because you know that cancellation on both sides is possible only when those are not equals to 0, right? So be careful while cancellations, otherwise you will be in trouble. So alpha to the power 4 you may remove it, no need to worry about it. So এটা নিয়ে ভাবার দরকার নেই. From here I will be taking common. So আমি যেটা common নেব সেটা হচ্ছে I will take common twice alpha sin alpha I will take common. If I do so, it turns out to be twice alpha sin alpha. So this turns out to be alpha cos alpha minus sin alpha. Okay. So from here you have three different options. So এখান থেকে তিনটে অপশন আছে আমার কাছে. The first option is alpha equals to 0. 2 you can cancel from both sides because 2 is not equals to 0. So one of the option is alpha equals to 0. Another option is sin alpha equals to 0. All this cannot be satisfied simultaneously. সবগুলো একসাথে satisfied হবে না. Any one will be satisfied at particular position. And this one is equals to 0. So these are the three options that I have presently. Now, out of these three options, okay, this is alpha equals to tan alpha. These are my three options. This is sin alpha equals to 0 and alpha equals to 0. Alpha equals to 0 you write already discussed to be the principal maxima. Already discussed to be the PM লিখে রাখলাম, হ্যাঁ, principal maxima. তাহলে alpha equals to 0 এই ইকুয়েশনটা বলছে this equation says that at alpha equals to 0 you have either a maxima or a minima, তাই তো? At alpha equals to 0 because this is generated from the first derivative 0. So this equation says that either you have alpha equals to 0, alpha equals to 0 is either a maxima point or a minima point. But you have already seen that it is a maxima, and not only maxima, it is the principal maxima. So you are left with two more conditions. তাহলে তুমি আর দুটো কন্ডিশনে তুমি পড়ে থাকো. There are two conditions, that is this one and this one. The others has been discussed. So now let us see what happens with them, right? So চলো এরপরে এটা করছি. Give me a minute. Okay, so I am done. Now, এবারে আমি লিখছি it can be shown that what? It can be shown that number 1, second derivative d2ip by d alpha 2 is greater than 0, মানে minima point for sin alpha equals to 0. And number 2, d2ip d alpha 2 is less than 0, মানে maxima point for alpha equals to tan alpha. Got it? So this is sin alpha equals to 0 for minima points and alpha equals to tan alpha corresponds to maxima point. Because you know that how to decide the maxima minima once you know the points, how to decide the maxima minima. I hope that everybody of you know it from your previous principles. You know everything about it, right? But you don't need to differentiate this. তোমার differentiate করার দরকার নেই. No need to differentiate because it will be a very complicated differentiation, because you see that this first derivative is already quite complicated. First derivative টা দেখো যথেষ্ট complicated, কিন্তু if you try to differentiate it once again it will be very complicated and leave it. So ছেড়ে দাও, করার দরকার নেই, ঠিক আছে? আচ্ছা, so rather আমরা এখান থেকে যেটা করব সেটা হচ্ছে for minima. So first of all I will be discussing the minima and then I will be discussing the maximas. So একটু minima গুলো discussion করিনি. Minima. So what are my minima points? So fine, so minima is sin alpha equals to 0, sin alpha 0 তে minima আছে, তার মানে alpha equals to n pi, যেখানে n এর ভ্যালু কি হতে পারে, n এর ভ্যালু will be integer other than 0, because n equals to 0 is already my principal, so is already my principal maxima. So n এর ভ্যালু 0 ছাড়া বাকি সবকিছুই হতে পারে, because n equals to 0 has already been taken to be the principal maxima. n equals to 0 মানে এখানে তুমি দেখতে পাবে, I will just show you, just wait. So alpha is equals to n pi. So what is my alpha? Alpha মানে কি ছিল মনে করো, what is your alpha? Alpha is most probably beta alpha মানে beta a by 2. Alpha is beta a by 2 and beta is k sin theta. So let us try to write it. So alpha equals to beta a by 2 and beta is equals to k sin theta. Alpha is equals to beta a by 2 and beta is equals to k sin theta. Again k is 2 pi by lambda. Standard k মানে 2 pi by lambda, so that is my n pi. You will understand that why did I take n not equals to 0. Just wait, you will get it. 2 is also getting cancelled. So very important condition that you get, a sin theta is equals to some n of lambda. So a sin theta is equals to some n lambda. Fine, fantastic, you get a condition. Now you see that if you put n equals to 0, these a and lambdas are not 0. Lambda wavelength is the slit width. So if you put n equals to 0, এখানে দেখো n এর ভ্যালু যদি 0 পুট করে দাও তাহলে কি হবে, sin theta becomes 0. But theta equals to 0 is already the principal maxima. You see, theta equals to 0 is already the principal maxima. Theta equals to 0. Theta equals to 0 is already the principal maxima. So that is why you cannot take n equals to 0. সেই জন্য তুমি n এর ভ্যালু 0 নিতে পারবে না. You have to choose something other than 0, right? So these are the conditions of your minima point. So যেখানে যেখানে minima থাকবে মানে dark fringe, dark points, you have this. And finally হচ্ছে for maxima other than the principal maxima. And finally once I draw the pattern you will understand. So here the maxima are of varying intensity. এখানে maxima গুলো কিন্তু varying intensity হয়ে থাকে। দেখো, the condition for maxima is alpha equals to tan alpha. Now how to do and what to do with this equation? So this is what I will be solving graphically. So whatever I will do is that I will write let your y equals to alpha and y equals to tan alpha. So this is what we will solve graphically. We will solve graphically. One method is you can solve by numerical methods. So numerical methods, suppose you use the Newton-Raphson method. So this, you see that by normal methods you cannot do it. So you need to use the numerical method. So ধরো তুমি numerical methods এখানে use করলে, we will solve graphically. So not the numerical method, because you see that if I use the Newton-Raphson method, so it will take some time, it will not be justified over here. So we will try to solve it graphically. So graphically solve করি. And graphically solve মানে I will take y equals to alpha, I will take y equal to tan alpha and their intersection gives me the value of the alpha. So আমি y equals to alpha draw করব, y equal to tan alpha draw করব এবং তাদের যে intersecting লাইনটা, so the intersection points will be my solution. And here you see that again you need the class of your first semester, the introductory classes where you are learning how to plot the functions. কি করে plot করতে হয় সেখানে তোমাদেরকে শেখানো হয়েছিল. So it has been already taught to you how to plot and you see that those classes are going to play a role over here. এবং সেই ক্লাসটাই কিন্তু এখানে একটা রোল তোমার কাছে এখানে প্লে করবে. So you see that what is actually going on. So this is some my pi by 2. This is some pi by 2 and then I need to take the pi. This one is my pi. So again 3 pi by 2, 2 pi, 5 pi by 2, okay. Similarly the negative sides. So as you know these points, this is the plot of tan alpha with alpha. These are the points of 0, this is pi, this is 2 pi, and this side also similarly, this one is negative pi, this one is negative 2 pi, right? So and the between the points in between, those are your pi by 2's. So these are pi by 2, this is 3 pi by 2, this is 5 pi by 2. Similarly on this side, this is negative pi by 2, this is negative 3 pi by 2, and this is negative 5 pi by 2. So this is how you plot the tan alpha functions. This doesn't need an explanation, already explained in your first semester course that these are the plots of tan alpha. Those who have not gone through the course properly, so jara hoyto koroni, so tara dekhe nebe eta hocche tomar tan alpha plot. This is just the plot of tan alpha versus alpha. So tan alpha versus alpha are of this type. You may just verify it. You just look that at pi by 2, you know that tan pi by 2 is infinite. So you see that as you are trying to put infinity pi by 2, this is going towards infinity. Therefore infinity dike jacche, this is going towards infinity. You try to put 3 pi by 2, it is going towards infinity. You put minus pi by 2, it is going towards what? So minus pi by 2 put call, it is going towards minus infinity, minus 3 pi by 2 it is going towards minus infinity, and so on and so forth. So এইভাবে পুরো সিচুয়েশনটা এইভাবে চলছে. So that is how the things are going on. Okay, so now let us try to understand the issues. So এবার একটু বোঝা যাক বাকিগুলো. So এটা হচ্ছে tan alpha plot. So this is the plot of tan alpha. So now if I just overlap the plot of I just overlap the plot of y equals to alpha over this one. So এটার উপরে আমরা y equals to alpha প্লটটাকে ওভারল্যাপ করছি. I am trying to plot this one. I don't know how much I will be able to do, কতটা করতে পারবো জানি না, but I will try my best. Yeah, fantastic. So the software has helped me a lot, so I have been able to plot it. So আমি প্লট করতে পারলাম. So this is my plot of, so এটা হচ্ছে আমাদের প্লট করলাম. So this is the plot of alpha. So this red is the plot for I just mark it over here. So this is the red color. So red color and then it's the magenta color. So I have used two colors over here. So this is the plot of y equals to tan alpha, and this is the plot of y equals to alpha. So this side I am plotting alpha and this side I am plotting y, and the intersection gives you the solution. Intersection তোমাকে solution গুলো দেবে. So this intersection gives you the solution of alpha, right? The solution of this equation y alpha equals to tan alpha, and there is one more solution at the origin. Origin is definitely a solution because at alpha equals to 0, alpha 0 and tan 0 gives the same value. Tan of 0 is 0 and alpha 0 is also 0. So 0 is also a solution, but 0 already you know that alpha equal to 0 is the principal maxima, and here it is what? These are for the maximas. So alpha 0 will be definitely included over here. So these are the general maximas. So in the general maximas, the principal maxima must be included. So principal maxima সেখানে থাকবে, তো সেটাই এখানে দেখা যাচ্ছে. So that is what I find. So now you see that did I write over here? So we will solve graphically, and the solution points are this. So I write it over here. Thus the required solution is the intersection of the above two plots. At the points, কোথায় intersect করলো? Where did it intersect? At the points alpha equals to 0. This is my principal maxima. And what are the other points? বাকিরা কোথায় আছে সেটা বেশি দরকার. That is nearly, plus minus. Look at the diagram. কোথায় হয়েছে দেখো. This point is very near to 3 by 2. এই যে পয়েন্টটা না, এটা very near to 3 by 2. This point is very near to 3 by 2. Had it been the exact diagram in the software যদি exact diagram হতো তাহলে দেখতে একটা 3 pi by 2 এর খুব কাছে. This point is very near to 5 pi by 2, and similarly over here also you see this point is very near to minus 3 pi by 2, and this point is very near to minus 5 pi by 2. So approximately I can take it in this particular way. So approximately আমি এটাই নিয়ে নেব. I will take it approximately. So alpha equal to 0 plus minus 3 pi by 2 plus minus 5 pi by 2. So these are my approximate points. So এইগুলো আমাদের approximate points. These are my approximate points where I try to find the solution. So thus the required solution is the intersection of the above two plots at the points like this. So এই জায়গাতে যে পয়েন্টগুলো আসে. However, the exact solution is something like this. However, the exact solution However, the exact solution is what? Exact solutions will be, however, the exact solutions will be these one. Alpha equals to 0. This plus minus 3 by 2 is actually 1.43 pi. So I got 1.5, but it is 1.43 actually. And this one roughly it is 2.5, but exactly if you solve it, so then it will be 2.46 pi. But you know that for exact solution you need graph papers and everything. Exact cut point টা পেতে গেলে graph paper থেকে আমাকে নিতে হবে, which is not possible in this type of theoretical classes. So we just approximate it to be 3 pi by 2, 5 pi by 2. মোটামুটি কাজ চালানোর জন্য 5 pi by 2 কাজ চলে যাবে না, 2.5 or 2.46 negligible. So you can just relate it. Okay, তাহলে এখান থেকে for first maxima. So here you see what happens for first maxima. So I put up a heading for first maxima. Alpha equal to 0 is the principal maxima, which I have mentioned a number of times. I am not going to discuss. So for first maxima, what happens? For first maxima, that is if I take alpha equals to plus minus 3 pi by 2. So what was my function? That was IP equals to I0 sine square alpha by alpha square. So that is sine square alpha by alpha square. So if I put this alpha 3 pi by 2, so alpha value যদি 3 pi by 2 আমরা put করে দিই এখানে, তাহলে যেটা হবে সেটা হচ্ছে I0. So this will be some first one I put it sine of 3 pi by 2. 3 pi by 2, this one is whole square. So sine 3 pi by 2 is 1, this is 4 by 9 pi square. So 4 by 9 pi square. 4I0 by 9 pi square. It is 4I0 by 9 pi square. This is the first one. This one is I1, I call it. So I1. So therefore I find that I1 is equals to 4I0 by 9 pi square. It is 4I0 by 9 pi square. This is I1 is 4I0 by 9 pi square. Okay. Now for second maxima, so what happens for the second maxima? Second maxima তে কি হবে? Second maxima মানে হচ্ছে, second maxima means it is alpha equals to plus minus, alpha equals to plus minus 3 pi by 2 is over 5 pi by 2. So alpha equals to plus minus of 5 pi by 2. So that makes it how much? So I2 will be, if you just plug in that particular way, so সেইভাবে যদি plug in করো, I2 will be I0 sine of 5 pi by 2, and then it is a 5 pi by 2, and that one is whole square. So this gives me 4 by 25. So 4I0 by 25 pi square. So I2 is 4I0 by 25 pi square. So what do you find over here actually? তাহলে তুমি এখানে কি দেখতে পাচ্ছ? What do you actually find? So you find that the I2 is like this, and similarly if you go for I3, and similarly I3 is equals to 4I0 is common. By this time you understand, and this one will be over here 36 pi square. Actually the first one was 3 square, then it is 5 square, so this one will be 7 square, not 36, it will be 49. So 3 square, 5 square, and then 7 square, that is 49 pi square, and so on. এবং এইভাবে চলতে থাকবে. So what is the idea over here? So the idea is that the principal maxima is I0. Principal maxima intensity কি ছিল? That was I0. And then the first maxima you see, it is less than I0. এটা কিন্তু I0 থেকে কম. This is less than I0. This is less than I0. Okay. So এটা কিন্তু I0 থেকে কম আছে এটা. And this one, this second one is lesser than I1, because this is divided by 9 and this one is divided by 25. So this is lesser, right? And I3 you see that this one is divided by 49. It 25 till 49. Other terms are same. So as you are moving towards the outer orders, your maxima intensity is decreasing. So maxima intensity কিন্তু আস্তে আস্তে কমে যাচ্ছে তুমি যত বাইরের দিকে যাচ্ছ. As you are moving towards the outer orders, your intensity pattern is gradually decreasing and decreasing in this particular system. So let us observe. Let us draw the pattern. Okay, so you see that these are my minima points that I am marking presently. So এখান থেকে তুমি দেখে নাও কি আসছে। This is the 0 point, the principal maxima. This is the plot with respect to alpha, not with respect to theta. এটা alpha respect প্লটটা হয়েছে। So this is 0, this is 0, right? This is for 0 এর পরে কি ছিল? The what are the minima points? Just have a look. What are the minima points? Where do you have minimas? Minima গুলো কোথায় আসে? So minimas are obtained at alpha equals to not 0, pi, 2 pi, 3 pi, 4 pi, and on the negative side also. এই alpha টা কোথায় কোথায় 0 পাই আমরা? Pi, if I put pi, right? So minima points, right? Minima points মানে which satisfy this condition, alpha equals to n pi. So alpha equals to n pi are my minima points. So that means that the minima points are what? You cannot take n equal to 0. You can take all other integers. That means plus minus pi, plus minus 2 pi, plus minus 3 pi. So plus minus pi, 2 pi, 3 pi, that is n pi. I have the minima. So this is pi, 2 pi, 3 pi. So these are my minima points. So minus pi, minus 2 pi, minus 3 pi. তাহলে এই জায়গাগুলোতে আমরা minimum পাই. So at these particular points we get minima. And where do I have the maxima? The principal maxima is at 0. The next maxima you see, the next maxima is at 3 pi by 2. The next maxima is at 3 pi by 2. The next maxima is at, sorry, I just mark it here for clarity, 3 pi by 2. The next one is at 5 pi by 2, and so on. This side also you have the maxima at negative 3 pi by 2. This is the first maxima. This is the second maxima, 5 pi by 2. And this is the central of the 0th maxima. This is called the principal. এটার নাম হচ্ছে principal or central or 0th order maxima. Okay, and this is of maximum intensity. That is why we call these names principal or the central. So এটার intensity সব থেকে বেশি আছে. Now this is a clear cut difference between interference and diffraction. So in the pure interference phenomena, you have noticed that all the bands were of same intensity. প্রত্যেকটা maxima কিন্তু same intensity ছিল in interference, and that was 4I0. 4I0 ছিল না এখানে maximum intensity 4I0, right? You have noted it. So নোট করেছিলাম আমরা. So that is what we have noticed in your classes of interference, but here you don't see. Here you see that the intensities of the maximas are of diminishing order. Let me write it. The intensity of the diffraction maxima, decreases with increasing order. The intensity of the diffraction maxima decreases with increasing order. Increasing order মানে increase in the angle of diffraction. Increase in the angle of diffraction. Angle of diffraction means you are moving outward from the center থেকে বাইরের দিকে চলে যাচ্ছ. The intensity of the diffraction maxima decreases with increasing order, right? Maxima এগুলো, these are all maximas, but you see that the intensity are of diminishing magnitude. And where from did I understand? I understand it from this expression. Principal was my I0 was my principal. Then the first one you see that is less than I0, এটা কিন্তু I0 থেকে কম. The second one you see all the factors are same, 4I0 by pi square, but divided by 25. The next one is divided by 49. So definitely the peak height is decreasing over here. এখানে কিন্তু peak-এর height কমে যাচ্ছে. So the diffraction maximas are diminishing intensity. First information. Second information is the bandwidth. So what is the bandwidth in this particular case? You see that the central bandwidth is 2 pi. Central bandwidth দেখো 2 pi এর ব্যান্ড আছে, কিন্তু the central is of a band of width 2 pi. If you notice properly, minus pi to plus pi, it is a band of order 2 pi. And next, these bands appear to be uniform, but they are not so. এখানে আপাতত দৃষ্টিতে apparently it appears to be pi to 2 pi, so it is a difference of pi. So this one is 2 pi to 3 pi, so this appears to be a band of pi, but these are not band of pi, because you know that whatever I have taken pi, that is approximately pi, it is not exactly pi, and whatever I have taken 2 pi, it is not exactly 2 pi. So not this one, the position of these ones actually, এই যে position, এই position গুলো, this 3 pi by 2, this 5 pi by 2, these are not the exact position, তাই না? এখানে এই যে 5 pi by 2 বলো বা 3 pi by 2, এই পজিশনস গুলোতে এক্সাক্ট পজিশনস নয়। 3 pi by 2 is not 1.5 but it is 1.43. Similarly 5 pi by 2 is not 2.5 but it is 2.46. So the distances between the maximas, so maxima গুলোর মধ্যে যে ডিসটেন্স গুলো আছে সেটাও কিন্তু তোমার এখানেতে ভ্যারিয়েবল। So the distances, so that means that the যেটা তোমার বিটা actually the fringe width in case of diffraction, what happens? The fringe width is not uniform. The fringe width in case of diffraction is not uniform. Diffraction এ fringe width কিন্তু uniform হয় না। So one difference, interference fringe width is uniform, diffraction fringe width is non-uniform. Secondly, interference, the intensity are same intensity but the maximas are of different intensity, and that definition, it is the interference between the interaction between the light waves coming from two different wavefronts for interference, but for diffraction it is the superposition of the waves coming from the same wavefront. So these are a few difference. You may find a few more in your books. বই খুলে দেখবে আরো একটা দুটো পেতে পারো, but you make a note of it. But এটা নোট একটা বানিয়ে নিও because এটা পরীক্ষাতে আসে. What is the basic difference between interference and diffraction, or some people may ask you. So this can be the differences that I point out over here, right? So I hope that you are getting the issues over here. So যে কথাগুলো এখানে বলা হচ্ছে সেগুলো তোমরা নিশ্চয়ই বুঝে উঠতে পারছো. So you are able to understand the issues over here. So one more thing I would like to discuss over here. So একটা রিমার্ক আমি করছি. Suppose a sin theta is equals to n lambda. So this is the condition for diffraction minima. এটা diffraction minima condition, তাই না? This is the condition of diffraction minima. লিখলাম diffraction minima. So for small theta, থিটাটা যদি ধরো আমি স্মল নিচ্ছি, স্মল থিটা, so I can write this a sin theta, a theta ধরে নাও লিখলাম, a theta, just for simplicity I write it, a theta n, that is n lambda. Okay, so theta n is equals to n lambda by capital A, n lambda by capital A. Now actually we used to say a term in diffraction that comparable to the wavelength. একটা কথা বলা হচ্ছে না, that diffraction is noticed only when the wavelength is comparable. The wavelength is comparable with the dimension of the slit. Slitের dimension আর wavelength যেন comparable হয়, মানে this lambda and a must be of more or less same value. Lambda and a must be of more or less same value, because if these are of same values, so then you will see that there will be appreciable change in theta values when you change the n. তুমি যখন n টা চেঞ্জ করবে তখন থিটা ভ্যালুর একটা অ্যাপ্রিসিয়েবল চেঞ্জ তুমি পাবে। যেটা স্মল ধরার দরকার নেই, you may not take it to be small. If you don't take it to be small, then it will be some theta equals to some sin inverse n lambda by a, right? এইবার আমি বলতে চাইছি, I want to say that if you change the value of n, so then theta n should appreciably change. So theta n টা যাতে চেঞ্জ করতে পারে, theta n টা চেঞ্জ করে যাওয়া মানে, what do you mean by the change in theta n? So theta n change করছে মানে this is for a particular theta and this is for another particular theta. That means that there is a fringe, you obtain a fringe like this. So এখানে একটা ফ্রিঞ্জ গুলোর মধ্যে একটা ডিফারেন্স তুমি পাবে, you get a difference between the fringes. Okay, this is for some theta 1 say, this is for some theta 2 say. So you see that you get distinct fringes over here. তুমি প্যাটার্নটা বুঝতে পারবে, you will understand the pattern that really there is some distribution over here. সত্যিকারে এখানে distribution আছে. But now you see that if this dimension is not at all comparable, যদি ডাইমেনশনটা যদি comparable না হয় তাহলে কি হবে? So if the dimension is not comparable, then what will happen? So the same thing will happen if sin is present or sin is absent. If you take the A to be very very large, এটাকে ধরো তুমি খুব লার্জ নিচ্ছ, you take A to be large in comparison to lambda. So wavelength এর ডাইমেনশনে নয়, তুমি জানো তো wavelength মানে কি, wavelength অ্যাংস্ট্রম অর্ডারে হয়, বুঝতে পারছো? So 5000 angstrom, so 5000 into 10 to the power minus 10 meter, this is the dimension of lambda, this is the value of lambda in the visible range. Suppose 5000 into 10 to the power minus 10 angstrom, তার মানে এটা তোমার কিন্তু 5 into 10 to the power minus 7, তার মানে এটা হচ্ছে 0.5 into 10 to the power minus 6, তাই তো? 0.5 into 10 to the power minus 6 মানে হচ্ছে 0.5 মাইক্রোমিটার। তো 0.5 মাইক্রোমিটার অর্ডারের যদি তোমার এই এটা হয়, 0.5 তো এক্স্যাক্টলি পারবে না, তুমি মোর অর লেস মাইক্রোমিটার, বিকজ ল্যামডা ইজ ভ্যারিং ফ্রম ওয়ান কালার টু অ্যানাদার কালার। সো তার মানে আমি বুঝতে পারছি দিস এ মাস্ট বি অফ দ্য অর্ডার অফ মাইক্রোমিটার। তাহলে এটাকে কি অর্ডারে হতে হবে? এ শুড বি অফ দ্য অর্ডার অফ মাইক্রোমিটার। Micrometer you have also done that is the film, that is the interference film that you are using to 2 mu t, that t, that thickness was also of the order of micrometer. So সেটাও মাইক্রোমিটার এর ছিল। So in the Fresnel biprism experiment you introduced a plate in one of the beams. That plate was also of the order of micrometer. So micrometer is actually used to be comparable with the wavelength of light. So wavelength এর সাথে কম্পেয়ার করার জন্য ইউজ করেছি। সো দেখো তুমি যদি ল্যামডা আর এটা যদি মোটামুটি সেম অর্ডারের হয়, ইফ দিস ইজ অফ সেম অর্ডার, সো দেন আই ক্যান জাস্ট কনসিডার দিস থিটা টু বি নিয়ারলি ইকুয়ালস টু দিস এন। তাহলে থিটাটাকে আমি এন এর সাথে ইকুয়াল ভাবতে পারি। আই ক্যান কনসিডার দিস থিটা এন টু বি ইকুইভ্যালেন্ট টু অনলি এন। সো এবার এন যখনই 1 থেকে 2 করবে, থিটা কিন্তু বেশ ভালোই চেঞ্জ করবে। দেয়ার উইল বি সাম অ্যাপ্রিসিয়েবল চেঞ্জ ইন দ্য ভ্যালু অফ থিটা, যেটা এখানে দেখতে পাচ্ছ থিটা 1 থেকে থিটা 2। দিস ইজ মাই ফার্স্ট অর্ডার ম্যাক্সিমা, দিস ইজ মাই সেকেন্ড অর্ডার, থার্ড অর্ডার এন্ড সামথিং গোয়িং লাইক দ্যাট। সো এইভাবে পুরো ঘটনাটা চলতে থাকবে। কিন্তু যদি এখানে এ এর ভ্যালু যদি বড় হয়, ইফ এ ইজ গ্রেটার দেন ল্যামডা, ইফ এ ইজ গ্রেটার দেন ল্যামডা, so what happens is that this theta n becomes very small. Theta n এর ভ্যালুটা, that is the separation from one order to another order, becomes extremely small. That is, if I want to get this, ধরো আমি এইটা করতে চাই থিটা n প্লাস 1 মাইনাস থিটা n, মানে ফ্রিঞ্জ উইথ যেটা। সো ফ্রিঞ্জ উইথটা তখন কি হয়ে যাবে? সো দ্যাট উইল বি সাম অনলি ল্যামডা বাই এ, শুধু ল্যামডা বাই এ অর্ডারের একটা হবে, এবং এটা তুমি বলছো অত্যন্ত বড়, এ ইজ ভেরি লার্জ। সো ইফ এ ইজ ভেরি লার্জ, সো দেন দিস ডিফারেন্স বিকাম ভেরি ভেরি স্মল। So then this difference become very small, right? Very small. তার মানে তুমি ফ্রিঞ্জ পাবেই না, as if you are not going to get the fringes. মানে তোমার কাছে ওটা তখন কি মনে হবে? It will appear to be some uniform illumination. There will be no diffraction. So diffraction যদি পেতে হয়, if you want to have some distribution মানে distinct bright and dark, একটা bright dark এরকম ভাবে তোমাকে পেতে হবে। বাট এখানে কি হবে? একদম কাছাকাছি, very very close, bright dark, and you cannot consider this to be some distribution. এটাকে তোমার ডিস্ট্রিবিউশন তুমি ধরতে পারবে না। You cannot consider it to be a distribution. Okay, so that is what I actually mean to say over here. So এটাই আমি তোমাকে এখানে বলতে চাইছি, that ডিফারেন্সটা যদি খুব ছোট হয়ে যায়, the fringe width is becoming very very small, the fringe width is becoming very very small, so then you will be unable to see that effect. তাহলে তুমি এই এফেক্টটা দেখতে পাবে না। আবার at the same time যদি খুব বড় হয়ে যায়, if it is very large, this width is very very large, লার্জটা তো হয়ে গেল। এবার যদি ভেরি স্মল হয়ে যায়, if it is very small in comparison to the wavelength of light, so wavelength এর থেকেও যদি তুমি এটা কম করো, যেটা বেসিক্যালি পসিবল হবে না কিন্তু, which will be not possible. Why? Because it is already micrometer. তুমি মাইক্রোমিটার থেকে কত ছোট করবে? So what can you make smaller rather than micrometer? So এটা তো একটা তোমার মানে this is a geometry that is human made. So তুমি যে width তুমি যেটা বানাচ্ছো, the slit that you are making, that is human made. So how can you make it further smaller than this? So এর থেকে আর কত স্মলারই বা তুমি বানাতে পারবে, রাইট? সো ইটস নট অ্যান ইস্যু। সো এটাকে স্মল করা ইস্যু নয়, ইস্যুটা হচ্ছে এ আর ল্যামডা কম্পারেবল হবে, এ যেন ল্যামডার থেকে বড় না হয়। The slit must not be very very greater than lambda, so then you will not be able to see such effect. তাহলে কিন্তু এই এফেক্টটা দেখা যাবে না, you will not find that effect over here. So the reason I hope that I have been able to make you understand. So আশা করি সেটা তোমাদেরকে আমি বোঝাতে পারলাম যে কেন সেটা তুমি পাবে না, why you will not get it over here, right? So this much for today's class, and here I will be winding up the lecture. So তুমি কিন্তু এটা একটু বাড়িতে পড়বে, that what happens when a is made smaller. So slit width যখন ছোট করে দেওয়া হয়, if a is made smaller, so then what happens? A is decreasing. So what will happen? এটা পড়বে, this is the question for exam. Read from the textbook and make a note of it. তার একটা নোট বানিয়ে রাখবে, right? So here I will be winding. Thanks to all of you for your kind attention.